What's up, guys? So our next target would be we are going to discuss Newton's divided difference formula for equally spaced data points. X point. Let's see what this means, right? I think you have remember we have done a small example on Newton's divided difference method. So we found Newton's divided difference polynomial for this data set. Just check out the data set. So this is your x component and this is your y component, right? Y component, right? And check the gap. So let's write out x data set, x0, x1. There are 4 data points. I just write the x coordinates of those data points, right? So this is according to this data points, this would be equal to -1, 0, this 1, and this one is 2. And look at the gap between distance between these two neighboring points. If you consider any neighboring points of x's, say let's look at this distance between x0 and x1. What is the distance? Just consider the magnitude. We are interested in quantity of that distance. We are not interested in the sign, right? So what is the magnitude? Magnitude would be 1, right? So the distance is 1, and here the distance between these two x's is also equal to 1, and this one also equal to 1. So this is called equally spaced points. So this is called equally spaced points. So these x's are called equally spaced points, right? So in this case, so now we are going to find the Newton's divided difference polynomial for this case. So if you have a data set, right? So equally so how do you say equally so if that data set is equally spaced data set, in this case, so for this case we are going to find the Newton's divided difference polynomial, right? Let's see how we find that, right? How do we find the polynomial for the equally spaced data set, right? All right, guys, so let's consider a data set, right? So x0, y0, this is the corresponding y, x1, y1, up to xn, yn. This is our data set, and this data set is called equally spaced one. This is your x0 and x1, x2, up to xn. If you take any two neighboring x's, say let's consider any two points. Say let's consider xi, and the difference between x sub I and x sub I minus 1 is equal to h. The same value. The gap between any two is equal to number h, the value h. So because this is equally spaced data set, right? All right. So x1 would be, what is the, so you can express x1 here in terms of x0 and h. So x1 is x0 plus h, right? So x2 can express x2 in terms of x0 and h. So x2 will be x0 plus 2h. X3 would be x0 plus 3h, right? And so on and so forth, right? So if you have x sub k or x sub I, that's consistent with notations, right? X sub I, this can be written in terms of x naught and h, I times h. So here h goes from, no, I runs from 0, 1, 0 to n minus 1. How many gaps do we have? So we have how many points? We have n plus 1 points. Then we have n gaps. Now, yep, that means this I runs from 0 to not n minus 1, n. Alright, I hope you understand, because here we have n plus 1 points, and the gap between, how many gaps do we have? How many subintervals? We have n number of subintervals. Alright, hope you understand that. Right, let's move forward. So here I am going to define the forward difference operator. So here I'm going to define the first order for forward difference operator, so which is denoted by this here, delta f of xi, right? Delta f of xi. So what are f of xi's? What are the corresponding y values for these? These are the corresponding y values, right? Right. So I will write this one is f of x naught, and this one f of x1, and so on and so forth. Right. So then I can define the first order forward difference operator as follows. So this is the forward difference. Basically this one would be y, according to our notation right here, y sub 0 is equal to this, y sub 1 is equal to that, then this would be y sub, and same thing, right, plus 1 minus y I. The distance between yi plus 1 coordinate, yi plus 1 and yi terms, right? So this one, so we define, so this is the definition, so you can write this. This is called the first order forward difference operator, right? Then what is the second order forward difference? operator, which is denoted by this f of so take this operator again, delta operate both sides. All right, and this becomes delta squared of f of I, which is equal to delta of f of xi minus 1 I plus 1 and minus delta of xi. So you can use that. This is the first order forward difference. So what is the definition for that? So forward, because of forward, so so first one would be f of x sub I plus 2, right? Don't get confused. I plus 2 minus f of I plus 1, right? And this is minus here, and let's open a bracket, and delta of forward first order forward difference of f, which is f of x I plus 1, right, minus f of x I think this is very important. In the exam, you are asked to write what is the first order forward difference and second order forward difference, third order, and so on, right? You will find a lot of MCQs asking you to write the third order. What is the third order forward difference operator, right? And you can write that out straight away if you know how you can do it, how to do that. And f of xi plus 2, here negative, you get two terms, 2 times f of xi plus 1 minus plus, here minus becomes plus f of xi, this is your y sub I 2 minus 2 y sub I plus 1 plus y sub I. So this is the second order forward difference operate of f, forward difference of f of xi, right? I think let's get familiar these notations. Let's write out this one using that notation, forward difference operator notations, right? So what is this one? This one, the gap between these two, f of x1 minus f of x0, that would be equal to, this would be equal to what? This would be delta, the first order forward difference of f of 0, and this one forward difference rate of x1, and so on, right? And what is this gap? So we know our data set is equally spaced, right? So the gap between x2 x1 and x0 is h. This gap is h, this gap is h, right? That means if you consider any, let's write that out, right? So if you have f of x0 comma x1, that would be delta of f of x0 So grab the pen. F of x1 comma x2 have delta of f of x1 divided by h. So alright, so f of xi minus comma xi minus 1. So what is the pattern there? Alright, small one. This is x0, then we get x0. So this is the x0 and next one is x1. All right, then we get let's write this way. All right, x sub I minus 1 comma xi, then so on the numerator the first order divided, how do you call that, first order forward difference operator of f of the least one here, this one here, xi minus 1 divided by h, right? The gap between these two is h, right? So we can rewrite this h times f of xi minus 1 comma xi is equal to the first order forward difference divided difference of f of xi minus 1. So this one is pretty very important. Similarly, we can write this one in terms of forward difference divided difference operator. So this would be delta of f of f1. This would be delta of f of what is this, x1 divided by h. This would be delta of f of x0 divided by h. This one is 2h, right? The distance between x and x2 would be 2h, right? That's why 2h. All right, let's simplify this. Then you get, so if you have these 3 points, f of x0, x1, x2 would be delta of f of x1 minus delta of f of x0 divided by 2h squared, right? So what is this one? This is the, so here you have, look at the definition here. So what is this? This is here delta of f of xi plus 1 minus delta of f of xi is equal to the second order of f of xi, right? This would be, what is that? So this would be the second order, this whole thing would be the second order f of x0. All right, that means here if you have 3 points, right, that one, so this one would be second order forward difference f of x0 divided by 2h squared. All right, look at this. If you have 2 points, so you get the first order forward difference operator of f of x0 divided by h. If you have 3 points, you have second order forward difference of f of x naught over 2h squared. If you have k terms, k plus 1, here look at the points. If you have first k plus 1 points, x0, x1, x2 and all the way up to xk, then this notation is equal to 1 over k factorial. You can prove this, h to the power k, and kth or the forward difference of f of x0. I think this one is pretty clear. I think you understand this one here, right? Alright guys, now we plug these values into here. This is your Newton's interpolation formula. This coefficient would be, you know that, what is that coefficient here? This is your a naught, this one is your a naught, this is your a1, a2, this is the last coefficient, a sub n. You plug, where's that? So you plug these things, these things to, where's that? There's the here. So this is your f of x naught, comma y1, and so on and so forth, right? You plug these things into there, into here, right? Then you finally, after plugging these values into here, you get this polynomial. This one is equal to this one. So if you plug these things into there, then you get this polynomial here. So this one, you get this one, right? Okay, so here you get products. The product, this is the product of x minus x naught, x minus x1, x minus up to x minus xk minus 1, right? Alright, let's consider this equally spaced x points, right? So here we had x0, x1, x2 and up to xn. We know these gaps are the same, right? These are equal gaps, right? H, right? The distance between any two consecutive x values is equal to h, right? So if you pick one of arbitrary x point, say xk, then we can write out this one. We can write this one in terms of x0 and h. So if you pick this one, say, then x0 is equal to x0 plus 1h. If you pick this then x2 is equal to x0 plus 2h. If you pick xk naught, which is equal to x0 plus kh, x0 plus kh, right? And let's consider any arbitrary x in this line, on this line. X is a point, right, in between x0 and xn, right? Then x can be written in terms of x0 and h as well. So here s is a parameter, so x0, right? So it is not it can be any real number. This is a some real number, right? So x naught, x is equal to x naught plus h times this real number, right? So this is not an integer, this is a real number, right? The x is a real number, so the distance between x and h naught, x naught is equal to h times this real number. So now you can consider this one here by subtracting this one from this, right? You get x. So when you subtract these two, this one from this, then you don't get x naught, s take away k, everything time h, right? So you get this. Now you can substitute this one here into these places, right? So x minus xk is this one. So what is this one then? X minus x naught is equal to sh, and x minus x1 is s minus 1 h, right? And so on so forth. X minus x2 is s minus 2h. So plug these things into here, then we get what you get, the summation mark. So this is the polynomial, right? And summation, what do you have? Summation k goes from 0 to n. Now this one, let's copy that down. K runs from 0 to n, and this is kth order divided difference of x of x naught, and divided by, I don't remember, factorial k. What else? I have a bad memory. H to the k. All right, then plug these values into here. X minus x naught would be sh, and another one would be x minus x1 would be s minus 1 h dot 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 dot, and the last one s minus k minus 1 h. So here how many h's? K number of h's, right? You can cross that one with this, right? Then you can simplify this. When you simplify this, k goes from 0 to n, kth order divided difference of f of x naught, factorial k, s minus 1 up to s minus k plus 1, factorial k. I took this factorial here, so I will give a notation for this part. So I will introduce a definition for this part. I will say this one is, so I don't know how to call this one. This one is something like binomial. Yep. So I will give this notation for this part, right? Then finally the polynomial would be this, your Newton's polynomial, n degree polynomial would be this one here, right? I hope you understood this one. So in my next video I'm going to do a small example on this, Let's see how do you deal with equally spaced data set, right? This is the derivation of that, right? So this is the n degree Newton's n degree interpolation polynomial for equally spaced data set, right? The excess, if you take the difference between two consecutive x's, you don't see any difference. So these gaps are the same, so these gaps are equal each other, right? That's why we call equally sized data set. So this is called equally sized data set when the x coordinate x points are uh, located here. If you consider these gaps, they are the same, right? So the x's are located equally spaced, right? All right, I hope you understood this one here. So in my next video I'm going to discuss a small video, a small example on this. All right, so see you in next video.